Boom! Yes folks, welcome to another video in our ongoing series of videos on the AdMaths project online platform as we continue to make our way through the AdMaths syllabus. So in this video we're going to start the discussion of the remainder theorem. Alright, now what I will do, as I tend to do most often, we'll go into a kind of long-winded discussion at the beginning to lay some roots, lay some foundations, so that your understanding of the thing will be enhanced when we start to get into the complicated stuff, the equations and the numbers and the values and the x and the y's and all of that, and the coefficients and the negative signs and whatnot. All right, so I want to encourage you very strongly. Do not neglect to go through this preliminary part here. Okay, it might be a little boring. Okay, it might be a little long, but what you should do, what you could do, is you could chop up the video. So let me say I spend 15 minutes talking at the beginning, right? The preamble is what we call it. Let me say I spend 15 minutes preambling, or 20 or 25 minutes, right? What you could do is break it up into 5 or 10-minute segments. You watch for 10 minutes, you pause, you get up, you do something else, you come back and you watch another 10 minutes again, and so on. So in other words, you have to find ways to get around the occasional boredom, the occasional tedium, the occasional lengthiness of the process. Right? I know that we live in an age where people promise excitement to sell things. Right? So it doesn't matter what you're selling. The goal is to sell it as the most exciting thing in the world. I am not here to do that. Right? I will try to make things as interesting and engaging as possible, but I am not going to promise anybody that it's going to be exciting from start to finish. There will be little moments of boredom in between. All right, so with that being said, enough talk, time for action. So, going back to our foundation tables, one-time table, two-time tables, whatever. So I choose a random pair of numbers, a random set of numbers. So we know that, for starters, we know that, let me see where to start, boy. We start in the corner here. We know that 9 by 4 is 36, all right? And we know that 36 divided by 9 is equal to 4. Right? This is an exact division, so in other words, 9 is a factor of 36. So you see we're bringing in the vocabulary already. All right? We know also that, I'll come in here in blue now, that if 36 divided by 9 is 4, we know immediately then that 37 divided by 9 is 4, remainder 1. All right? This is normally how we would write it in primary school or wherever. So we'll say 4 comma remainder 1. This comma here is very important because when we're doing the arithmetic, you'll see why I put that. So if for the sake of argument I had started over here instead of here, so in other words, the starting point would have been, instead of 9 by 4 is 36, which was just a reminder of your 4 times tables, or your 9 times tables, depending on how you want to look at it. If we start by saying that 36 divided by 9 is 4, it means then we could also write this by saying that 36 is equal to 4 multiplied by 9. Okay? Now, I seem to be going around in circles, right? I know, but watch this here. If 36 is 4 by 9, then 37 is equal to 4 by 9 plus the remainder of 1. Right? Let me say plus 1. All right? This one here is your remainder. So in other words, you're not cross-multiplying the 9 by everything in here. The only place you're doing the arithmetic is here with everything before the comma. The remainder is just the remainder. The remainder is not part of the arithmetic. All right? So 36 is 4 by 9. Cool, we know that. We know that at the back of the copybook. 37 is the same 4 by 9, which is 36, and then you plus 1 as the remainder. We start off with simple numbers that you're familiar with, and now we're going to get a little more general now. So if instead of 36 and 9 and 4, we start to go more general now. So now we could start talking about, what's the language now? We could start saying, if I have a dividend, right? That is the thing you're dividing, and I divide it by a divisor. The answer will be a quotient, right? The answer will be a quotient, comma, plus a remainder. Yeah? That is the general state of affairs. If this remainder here is 0, it means that the divisor is a factor of the dividend. Or alternatively, we could say that the dividend is a multiple of the divisor. So again, let me substitute some numbers here. Using the same template here, all right? So if we say on the one hand that 36 divided by 9 is equal to 4. 36 is the dividend, 9 is the divisor, 4 is the coefficient. In this case, the remainder is 0. So we know that 9 is a factor of 36, which we could say alternatively as 36 is a multiple of 9. Fair enough. If we come now, change up the colors a little bit here now. If we come over here on this side and say that 37 divided by 9, just as we did before, is 4 comma plus 1. The remainder here is 1. So we see in this case where 9 is not a factor of 37, right? 9 doesn't go into 37 exactly. It goes into 37 4 times, which will give it the 36 plus 1, which is the remainder. So in both cases, we're following the general trend, right? And you will see a little later on that in the general sense, we refer to the remainder theorem. And the factor theorem is a special case of the remainder theorem where the remainder is 0. All right? So we're going to rub off these two things now, go a little further with this guy here, and then bring back the numbers again. So we're still following this template here in black. Yeah? Now, if we cross multiply, remember we're doing the arithmetic here, not here. All right? So we say that the dividend is equal to the quotient in brackets by the divisor in brackets, comma, plus the remainder. All right? So in other words, when we cross multiply, the dividend will be equal to the quotient multiplied by the divisor. And if the divisor is not a factor of the dividend, you end up with a remainder on the outside. So again, if we could use the figures to demonstrate the point, we say that if 36 divided by 9 is 4, remainder 0, then 36 would simply be equal to 4 by 9. Yeah? 4 is the quotient, 9 is the divisor. And by the same token, we saw that 37 was 4. 37 divided by 4 was 37 divided by 9, sorry, was 4 remainder 1. Excuse. So it means then that 37 is equal to 4 by 9, comma, plus 1. The 1, of course, hold on, eh? The 1, of course, being the remainder. So again, we use simple figures to demonstrate, to illustrate some general trends that we're going to use. And we're going to get even more general now. And here now is where we step into the more mathematical notation. So pay close attention. If you need to, you could pause here, get up, go and do something else. pull your concentration back together, because you're going to need it in greater quantities as we proceed. All right, so we're rubbing off there. Now, this general trend works with regular figures, as we could see. It works with different types of numbers, whether you're talking irrational numbers, decimals, fractions, surds, rational numbers, real numbers, whatever. All right? But it doesn't just work with numbers. It also works with expressions. Different types of expressions, of course, which we wouldn't get into in too much detail, but we could refer back to the foundation that we're using in the advanced course, which is the polynomial expression. So this logic, this reasoning functions the same if we're talking about polynomials. So I'm going to use some mathematical notation now. Pay attention. So if we say that the dividend is some function of x, just to be general. So we say capital D of x. All right? And we divide by a divisor, common D of x. That is equal to a quotient Q of x, comma, plus a remainder R. This is a general equation. And then, of course, where would that take us? It means then that following off from this, that the dividend, big D x, is equal to the quotient Q of x dot small d, hold on, small d of x plus the remainder R. All right? These two equations, very important, and you will see why that is important. So what I will do here, I will pause the video here. In fact, I will stop the video, and we will start the very next video from this point. So make sure you have an idea, make sure you're clear about everything that we would have gone through in this video. So I devote one short video at the beginning, just establishing the basic foundations. The relationship between your divisor, your quotient, your dividend, and your remainder. That's an important set of relationships to understand. So now that we get to this point, we could end this video here, and we will start the very next video right here, and we'll proceed as we go along. All right? So looking forward to having you in the next video, and I hope you enjoyed it just as much as you enjoyed this video.